Good afternoon. We are team number 6. I'm joined together with my colleagues today, Kevin Vila, Gabriel Perez-Figuerola, and myself, Michael Suarez, and we'll be presenting the race car design. Ever since automobiles have been designed and manufactured, they've been racing them in various categories and sanctioned events and disciplines of racing. Formula One is one of the highest forms and highest level of racing, and one of the greatest examples in order to visualize the step-by-step race design process. As well as the Formula SAE, it's a collegiate competition held by engineering students that as well is very similar to an F1 open-wheeled race car design. Our project goals today will be a little historical improvements of Formula One race cars, as well as design specifications, describing the overall entire process that goes into designing a race car from start to finish, as well as the future design alternatives and an overall conclusion.
As the late 1940s hobbyist sport went to the 50s, so too did the requirement for a more high-end car. In the 50s was a time of advancement, as can be seen by the swapping out of drum brakes to more efficient disc brakes. Along with that was the inclusion of a rear mid-engine, which gave the car for Formula One a much better center of gravity. Sadly, in the 60s, early 60s, there was the death of two famous Formula One drivers, which caused CIFA to have to make several laws to save drivers. The first one being the reduction of the amount of fuel needed for a car. Along with that was the introduction of a new chassis design called the monocoque design. Along with this new design was the design of a new driver's seat, which had drivers laid down on the bed of the car to both reduce the risk of them being damaged when tumbling, if the car does tumble, and also reduce and lower the center of the gravity of the car. Along with this, in the later end of the 60s was the inclusion and usage of the wing design, as can be seen here in this original Formula One design. The 70s and 80s was a time of innovation of new and odd things, the first being of the Lotus 72, which removed the iconic use of a front exhaust and used a front wing design, which gave more aerodynamic stability. Along with this was the odd inclusion of the Tyro P34, which had 4 front wheels, which gave it better grip on the track. Now, along with this, in 1981 was the inclusion of the more commonplace carbon fiber monocoque chassis, which gave it a much lighter and more durable design. And in the 1990s and present day, we see the use of an active chassis in the FW14B, which gave a computer system enhancing the car and the driver's inputs as to give them a safer environment and regulating anything bad would occur. Along with this was the fuel regulations of the later 90s for a more economic and green earth-friendly environment with the use of only hydrocarbons. As can be seen here, both models are similar for the 1990s model and the 2016 model, although the 2016 model is a much more refined and efficient vehicle, which can be seen with all the minor changes and additions added on. And now with Kevin with the design specifications. Thank you.
Formula One cars are made up of various components that have very specific functions, such as aerodynamics, ergonomics, suspension, powertrain, and chassis. And over the years, each of those components have undergone exponential change due to sports regulation rules and high level of competition. The figure on my right shows the evolution from F1's inception to where it is today. Aerodynamics. Aerodynamics is a key feature in improving an F1's efficiency on the track. The front and rear wings allow for the elimination of lift and the increase of downforce. The enhanced geometry of side pods reduces drag as well, and body innovations improves airflow to the powertrain. The above example on the right is an older car which has little aerodynamic intent on the design. The lower figure is a CFD rendering which can determine the coefficient of lift and coefficient of drag. Ergonomics. Ergonomics takes into account the comfortability of the driver and the packaging of the components. Ergonomics were not taken into account in early designs, and the rearview mirror also aided in helping drivers look backwards. The addition of paddle shifting in the steering wheel allowed for a smoother transition between gears whenever the driver was changing gears. The suspension. The suspension is responsible for handling the lateral forces from the tire to the chassis. The figure to my right shows all the force relations between the wheel through the suspension to the chassis. The introduction of active suspension improved the overall handleability of the vehicle, whereas the independent suspension system improved the cornering of the vehicle. Now, the powertrain and the chassis. The powertrain is the heart of the F1 car. It takes the power from the engine through the powertrain to the tires. The chassis is responsible for two things. One, the driver's safety, and two, to be a frame for all the components to fit onto the car. The carbon monocoque frame is the standard that is used today, and the sequential gear system is what they use to achieve seamless gear change and faster gear times and lap times. I will now pass it off to Mike for the design process.
So the overall design process of a race car hasn't really been established as a step-by-step. But if we had to put it in one, this is how it would be. So first you would start with your analysis in the green, and then you'd follow through with your constraints and goals, preliminary designs, detailed designs, testing, and final development. Going in depth, we'll have analysis first. So in analysis, you gather a lot of information establishing all your goals and constraints within the actual car and placement of categories. So since we're dealing with F1, a great example was back in 2010 when they banned the option of refueling. It forced the teams to have to build a larger fuel tank in their designs. Also, performance analyses are conducted between previous designs in order to find and identify strengths and weaknesses. Constraints and goals and specifications. Your constraints are all relative to your technical and your sport regulations. So technical related towards your components, and sport regulations to all the rules and guidelines given by your competition. Goals are all related to the following listed: performance, handling, structure, drive accommodation and safety, and lastly, adjustable features. Your preliminary design are basically like your napkin sketches. So this is going to be an idea sketch of your general arrangement of components, the packaging of these components, your center of gravity location, your main track width and wheelbase, as well as basic CFD analysis and scale models. Your detailed design is where you get really in depth as far as overall dimensions of your vehicle, the complete locations of each component of the vehicle, as well as CFD analysis and simulations within a wind tunnel, as this example picture up on top. Multiple iterations of these processes are done in order to get a refined, perfect product at the end. Testing is done in order to confirm the behavior and mechanical and aerodynamic design that was made up, as well as the reliability of the components and structures within your vehicle. And it also identifies possible problems within your system to later then aim towards reducing costs. Development process is one of the most demanding parts because it happens all the way throughout race season. So from race to race, you're looking for updates within your design, as well as coping with other teams' improvements, and mainly balancing the possible gains within possibly the actual achieving it. Future designs that we came up with as alternatives were incorporation of innovation between both the Formula One and Formula E, which is the electric version of Formula Racing. For example, the Formula E braking recovery system can be implemented in Formula One, as well as coming up with more weight-efficient integrated systems that will go beyond pure combustion engines. Here's a great example of a hybrid engine used by Mercedes in Formula One racing. Conclusion: in the beginning of auto racing, there wasn't really any regulations or designs to go based off of. Everybody just hopped in their cars and went for a race. Design process is everything in order for a successful design or a successful race build. All vehicle components need to be taken into account in order for the design process to be followed through correctly. commercial vehicles have also benefited from a lot of innovative systems that are relative to Formula One racing. One example mentioned by Kevin was rear view mirrors, as well as hybrid engines, and etc. That is our presentation. Thank you for listening. Have a great day.